Use the product and quotient rules to find the derivative of exponential functions with base e. So for our first example, we want to find the derivative of x squared times e to the x power. And hopefully we can see here that we are going to need to use the product rule because it is x squared times e to the x. So let's quickly review the product rule. So the product rule says that if we have f of x times g of x, the derivative of that is going to be f prime of x times g of x plus f of x times g prime of x. Alright, so that just means we need to identify our first and our second function, find the derivatives, and throw them all together. Alright, so let's see. F prime of x then is going to equal, I'm going to call x squared my first function, or f of x, and I'll call e to the x my second function, g of x. So product rule says we take the derivative of the first function, which is 2x. We're going to leave the second function alone, which is e to the x, plus the first function untouched, which is x squared, times the derivative of the second function, and as we know, the derivative of e to the x is just e to the x. Boom! Alright, then we just have to see if there's anything we can do to simplify, and there's not a whole lot. We can just basically drop the parentheses to get 2x e to the x plus x squared e to the x. And there we have it. Boom! Done! Derivatized! Alright, our next example now asks us to find the derivative if f of x is equal to sine of 4x times e to the 7th x. And again, since there is multiplication here, we are going to need the product rule. So, first function is sine of 4x. Second function is e to the 7th x. But wouldn't you notice that there's a 4x inside of sine of x and a 7x inside of e to the x, which means both of these functions are going to require the chain rule. So we have chain rule inside of a product rule. Oh boy, what fun. So f prime of x is going to equal, let's see, we want to take the derivative of our first function. So let's see, the derivative of sine is going to be cosine. We're going to put the inside back in, which is 4x. And then we need to multiply by the derivative of the inside, and the derivative of 4x is just, is just 4. Alright, and then we just bring down the second function, e to the 7x. Plus, we leave the first function alone, so that's just going to be sine of 4x times the derivative of the second function. Well, the derivative of e is just e. Then we're going to put the inside back in, so 7x. Then we're going to multiply the derivative of 7x, which is 7. Alright, so the derivative has now been taken. So now we just need to simplify this as much as we can. And there's not a whole lot we can do here, but we can move the 4 and e to the 7x in the front, or sorry, we'll move the 4 to the front, and then we'll do cosine of 4x times e to the 7x. And there's really no order in which you want to put those in, so don't worry about that. It's all multiplication, so it's commutative. So you put the 4 in the front, and boom, good. Next up, we'll do 7 sine of 4x e to the 7x. And there we go. There is our derivative. Now, quotient rule. We want to find the derivative of 0.9 e to the x all over tangent of x. Quotient rule. Ah, dang. Let's do it. So let's remember the quotient rule. So if we want to take the derivative of the top over the bottom, quotient rule says we take the derivative of the top, multiply it by the bottom. Then we subtract the top times the derivative of the bottom all over the bottom squared. So let's identify our top and our bottom. We can see here that our top is 0.9 e to the x, and our bottom is tangent. So let's get to work. F prime of x is going to be equal to, alright, the derivative of the top. So we need to take the derivative of 0.9 e to the x. Well, remember, we can ignore coefficients, so 0.9 won't change. And the derivative of e to the x is just e to the x. So boom, done. Let's see, then multiply times the bottom, which is tangent of x, minus the top, which is 0.9 e to the x, times the derivative of the bottom, and the derivative of tangent is secant squared of x. And this is all going to be over the denominator squared, which just is going to be tangent squared of x. All right, so we want to simplify this next, and as usual, or as usual in this video, there's not a whole lot that we can simplify. So we can drop the parentheses, and we're going to have 0.9 e to the x tangent of x minus 0.9 e to the x secant squared of x, and that is all over tangent squared of x. Boom, boom, boom. There we have it. We have just successfully taken the quotient rule with the exponential function. All right, folks, that is it. That is using the product and quotient rules to find the derivative of exponential functions with base e.